thank you. Yeah, the important thing is I'm talking about today about customer visible data view visualizations. This is an important attribute for the choice of technology later on. Yes, as already mentioned, I'm a data scientist. I normally work on backend stuff like Arrow and Parquet. I'm typically around with Python and C++. I'm not the typical UI guy, but there are things you're facing to do in your work life, and sometimes really good, nice things come up. In the talk, I wanted to show a bit why do we actually want to have these dashboards, why we actually have sometimes problems building those dashboards, which extend a bit more than just building software, and how we got a compromise, how to effectively build these dashboards with everyone happy in the organization. And at the end, I want to show how really done technically with some code. Normally, we have data science products, we have machine learning models, and we have also users that use these machine learning models, and they are not tech people. They don't understand what our models do, so these models are black box to them. And for those, we need them to present those visually, what actually happens, what is the output, what is our machine learning model doing. This may be even helpful for us as data scientists when we want to understand what is my model doing on a high-level perspective. There is something where you need a UI, a dashboard. If you have also tasks which you want to do very often, even if you're tech people and can use the command line, sometimes it's easier just to have a UI where you can click through visualizations. Then you really want to build something where you can go fast through it. And also, as already mentioned, there are a lot of non-tech people. So building an API which is easily usable is not possible if there's some manager or, for me, it's grocery store manager. They cannot use an API. They need something to click. But also, my talk is a bit about building an end product for customers. For us as data scientists, there's already a really good toolkit, which is pure Python, where you can use. It's Bouquet. Bouquet is a plotting library, but also Bouquet brings with it Bouquet Server. And you can use Bouquet Server to build Python dashboards which directly interact with the browser with your backend code. So in this example, you're just creating with these 15 lines of Python a web page which has a button on it, an input, and if you click on that button, a routine on your backend is triggered, which then also, again, ran as an output in the front end. And that's all code you need to generate this behavior on the right-hand side. That's really nice. If you're a data scientist, it's pure Python, so it's perfect for you, so you don't need to learn any front-end code. But actually, this is not something we could have used in our environment, because we're not all data scientists. Bouquet is great, but it's an environment to write it in purely Python. That's the main selling point of it, but it's also one of the disadvantages of it, because we have front-end developers. Front-end developers can make us really awesome UIs. They can really style them really good, but they're not Python developers. They develop in JavaScript and also everything that's around. And if you give them Python, they're really, I don't want to use Python. And then also, Bouquet doesn't really directly render in Python code, but there's also some JavaScript in there. So you have widgets in Bouquet, which then in the end are generated by Python code that outputs JavaScript, which gives a bit of indirection and makes it for front-end developers a bit harder to do this. And if you have a customer UI, you really want to care about the usability in the front end and how easy your front-end developers can extend it. Also, you can use Bouquet. Say your front-end developers are happy to work in Python, then you still have the problem that the Bouquet, the front-end library, introduces its own set of JavaScript requirements. And these are not so sandboxed as the front-end developers would like them, which also makes the front-end developers a bit angry then. But still, if you don't care about a front-end UI and you just want to write a dashboard that's for you, that's for your data science team, you're probably really good off using Bouquet Server. But as we're building an end product, we need to care about front-end developers. Front-end developers, they have their own ecosystem, and they want to use it. They want to work in JavaScript. They want to work with CSS, there's maybe Sass, HTML, and so on. They want to use the dependencies from their ecosystem. They want to use the newest latest stuff that's available. And they also don't want to be constrained by us. And also, they would like to have minimal dependency on the back end. And then, when you give them the freedom, they can build your widgets around your visualizations, user interactions, navigation menus, and they're really, really productive. But that's all only happening if you don't constrain them too much. So you need to find a compromise between you being able to do everything from the back end and your front-end developers being able to really style your UI. One of the nice things to get separation is Vega and Vega Lite. Vega is in itself just a JSON specification which you can use to describe plots. And you can describe an awesome number of plots. So all these visualizations up there, they're just rendered out of this Vega specifications in JSON. And it's really wide grammar. Because of that, it can get complex. There's also Vega Lite, which is a more high-level approach, which you can use for plotting and charting, and where you have to write less expressive JSON statements and still get a lot of plots available with it. Which has the big benefit, you have a protocol between your client, between your Python backend and your JavaScript frontend to push big, good visualizations forward and back, and you have a really stable standard which you can rely on. But in the end, you as a backend developer also will want to develop some prototypes, and also want to develop some prototypes in that ecosystem. That's why your front-end devs also have to be a bit careful about what they pick. In our case, we picked Vue.js, which is one of those trendy, probably at the moment #2 front-end development frameworks. Vega is cool for your plotting, your visualizations, but for all the widgets around, you need something else. It doesn't have to be Vue.js, it could also be React or so. The important component in here is it should have capabilities that you can start simple, so that if you have or all the data scientists can then maybe in 5 minutes or so push up a first prototype and also integrate something in it. They may have to write 1 or 2 lines of JavaScript, but they shouldn't know any deep knowledge of JavaScript or the framework. So the basic requirement on the front-end framework also has to be simple level for the first prototype. It can go deep if you're really doing fancy stuff, but at the beginning, it should be simple. As a short demo, yeah, it's sadly on the wrong screen. Yeah. So JavaScript also has a nice framework around them. And its package manager, npm, is also not only a package manager, but also controls your environment. You can use that to... okay. So it also has its development environment, its framework, and its package manager also deals a bit about environment and scripting, which gives you then at the end, when you build such an app with kind of those advanced JavaScript frameworks, you have one command normally like view init and then use the name of a template. It sets up a project template, and then you say npm install, and you have all your JavaScript requirements installed. Then you have 2 entry points normally. You have the template will give you some headings, and there's space to input your widgets and the code that controls your widgets. If you're only doing a prototype, which is not about styling, you actually can go really far by not doing so many things. You can just run what they have, the template, and push run. The really nice thing about JavaScript, it has hot reloading. Hot reloading, it will not just start your web page totally new when you change something in the background, but it will only load those parts of a website new which you changed when editing. That's something I would really like to see in Python. It's probably much harder to do this, because in the front end you can just see, okay, it's just this one box, and we have to render this one new. But it gives you really fast feedback in development, so you normally don't have to restart a server. And as we do in Python, we also have to start a Python server to get this demo app up. I'm going to show the code afterwards. We're starting a Python Flask server simply that runs on the back end and will serve us some plots that we later on then visualize in the UI. And keep this a bit in mind. This is now the demo, which now how much code is in there. It's a simple template which shows you how a Vega plot looks like. It's a really simple one. I have put in a demo data set, which shows you a bit of comparison of how far an automobile can go compared to horsepower it has. And in the back end, we just randomly regenerate this data, so we have some plots to see how it behaves. And it gives you a bit of interactivity. And also, Vue.js is a mighty framework, and you get really simple lines of code. Already some things like a control bar at the side, which you can expand and add a menu or so without writing any code. That's an important thing. Or you just write a bit in your template, and the framework, in the basic way, connects it for you. Now, when we want to see a bit of code, I'm not 100% sure how much you can see of that code. As already said, a Vega specification is a JSON snippet. So writing a Python backend server actually just means you need to have some server which returns a bit of JSON in the backend. In this case here, I have a simple Flask app, just 4 lines to initialize the Flask app, and then I call JSONifier in a big Python dictionary, which then returns a plot, which in the browser looks like the one on the right-hand side. So the rendering is all done in the browser. We just made this one JSON. It's quite handy if you have a simple, small plot, then you could just write the Python dictionary and use that. But in the end, that's not totally handy if you have more data, if you have more complex plots. And for that, there's the partly new library Altair. Recently had its 2.0 release, which brings some really nice features to it, like better concatenation of plots, or also what I'm not going to show, but it's also a really nice feature of these Vega things. You also can have interactions in the plots. So if you have multiple plots and you connect them together, you can pan and zoom, and these plots also then are connected and also zoom in the other plots without you writing any extra code, which is also really a nice feature if you have a UI and your user should be able to select on the front end a bit about what they're seeing and want to drill a bit into detail. If you have Altair, you can simply put this data in a pandas data frame, pass it to the charting library, and call 2 lines of code, which then renders the chart as in Python dictionary, which then is passed as JSON to the browser. Or even better, if you're in a Jupyter notebook, if you run this one line, and it's the last line in your cell, it will also just show the chart. So there's already native integration for Jupyter. My demo I've shown is made up of 3 snippets. The first one is we have a Flask app. The Flask app in the back end, it uses from Vega as a cast data set. We just use it as an example, put it into a data frame, so that I don't only get always the same plot, I'm using the data, I'm calling Altair and say, please generate me an XY bar chart, scatter plot, and just randomly select one of these columns I specified, which are plottable columns. And I get a nice scatter plot in the front end, which here makes me my full backend app. I'm going to talk a bit later more about Altair. The thing is now, what we lost with not using something like Bouquet, there are also other Python-only front-end dashboard libraries, we lost a bit that we in pure Python. So we have the trade-off, we have to use JavaScript. Our front-end developers are not really happy because that's where they live. My fellow data scientists are not so happy because they're not in Python. But the really good thing is normally you don't have to do so much things if you write a proof of concept, which then from it, front-end developers will later on evolve to fully fledged customer UI. And in this simple example, we have a part where we write JavaScript. So this is all JavaScript I have written for the UI, which I've shown. The first line says you're going to import Vega embed. Vega embed is a library which just takes its JSON specifications and displays and visualizes them in the browser at the point where you specified it. The speciality about Vue is you have a dictionary in JavaScript where you define all your methods you will call. And we have here one method, it's called reload image. And we will call this method when we click on the button, which I made reload. All of this does, it calls our endpoint, which is in my case, it's Vega example. And when that endpoint returns a response, it parses it with the JSON parser and then passes it in to Vega embed. Vega embed takes 3 arguments. The first one is a path to an HTML element. In my case, I called it Vega box. The Vega specification or the Vega Lite specification. In this case, it's Vega Lite in normal case because most of plots you do with Altair are simple plots that can be rendered with Vega Lite. At the end, I'm setting also some options. In this case, actions false. Normally, if you use Vega embed, it will also put you 3 buttons at the top, like view source, save, and something else. And that's not something, if I make a custom UI, I don't want that. That's really nice for debugging, or if I'm in my Jupyter notebook, then I can inspect what JSON was generated. I can save the image also. But if I have a custom UI, I want a bit more control about what is shown. My non-tech users are not interested in the JSON source of my plot, so I don't want to clutter the front end with those buttons. And then to render all the front end we have a template which also gives us the menu, which you don't need to write. We have to put the button under and the box where we can put our image into, which basically means we put there a container, and also in the example there was already a slide transition, so when you close and open the menu on the side, it gives you a nice transition. I left it in there to make it a bit more code. But in the end, the essential things you need is internally there's a layout. And the layout means I have a box in the middle of my page, and there's a button on there which is called a V button here. And with @click.native, I'm saying, okay, there's a routine that should be called when I click on that button. And on the line below, I have the element called Vega box. This is the one I'm using then to show my image. At the start of the page, it's just a placeholder. Once I click on the button, a visualization is displayed. This is already, for me as a backend developer, doing these visualizations enough to get some input. Normally, you would also put some maybe 1 or 2 input elements in there because you're not only showing one visualization. There's always fixed, it just needs to be reloaded. But probably you have some input in your model and you just want to select which of those inputs should be used and should be displayed. Maybe you want to tune some parameters and change it, and then you get this output there. But it will be that you write 2 or 3 lines of Vue code, and then you write maybe 2 or 3 or 5 lines of JavaScript code, and in the end, you have your proof of concept. If you want to have more styling than in your front end, you also have to invest in JavaScript. So this is always your choice. But the important thing is we want to write something here where Python developers and JavaScript developers can coexist and can create a really awesome product. This example is online. I will also put the slides online. Then you can click on the link. there's also a README which steps you have to take to reproduce the example. Showing it to you, it's easy. As a JavaScript, it will also be a bit amazing for you because it's a simple example, but it will probably install about 800 dependencies or so. But that's just typical JavaScript use case and don't need to care about that much. That's basically how you build a UI which is suitable for Python and JavaScript developers both. But there's, I'm used to the Altair library, and the Altair library is really cool, so I wanted to show you a bit about the Altair library. In the examples now, I used again this cars data set, and you need these 3 lines at the top to get the example working. There's also a much longer Altair tutorial, and you could make a whole long talk about Altair. So also click on the link, look at the notebooks, they're really nice, and they also share about something about interactivity. But Altair is based on the idea of the grammar of graphics, which is also enough to talk about in a whole talk. But at the basic, it gives you a thing about to incrementally build up a plot. So if you're doing an Altair chart, you normally first say to it, I have my data, which in this case is my data frame called cars, and I want to have a scatter plot. In this case, I say mark point. And I maybe have 20 columns in my data frame, but I just said mark point. So all the plotting library knows to do is put a point in the middle. I can then say, okay, then use for x-axis miles per gallon. I get a scatter plot, 1-dimensional. And I can vary it. I can say mark tick, which gives me these ticks instead of points. But for my following example, I will stay with points. You can then say, okay, give me a y-axis. This is horsepower. It just adds this to you, and you build it up incrementally by adding attributes and seeing directly the change by putting one in another way. And you can also say I have then use my 3rd column origin to color my scatter plot. The nice thing is about Vega and Altair, or Vega Lite and Altair, what you're doing here quite maps to what Vega Lite is doing internally. This is also building up in the JSON specification as a grammar of graphics. There's some more amazing things there. Like you can also do aggregations inside of Altair, which is then done live in the browser. This is really nice if you have 1 or 2 plots connected. Then when you zoom in one plot and both plots are connected, it will also just select this data in the front end then. But it also means this amount of data has to be able to be stored in the front end, and only the aggregations on the data that are in the front end are then done. So, short summary, we went to use some technologies to build UIs that make everyone happy, not just the Python developer, but also the backend developers. We talked to each other. That's also how we got to the stack. First, we had Python developers suggesting one stack, then JavaScript developers suggesting one stack, both being unhappy. But the good thing was we talked and we got a solution. So if you also have these problems, just talk. It's the easiest way. And also, if you're selecting tools, think about who all is in your team, not just what is the best for you, so what's the best for all your team colleagues. And also, Altair is really nice. It's not even, you don't need it for UIs. Mostly, it's also used in notebooks. Just try it out. It's easy to use. And it's also fast. So that's the main thing of my talk. Now I should do 10 seconds of advertisement for my colleagues, which are also doing a PyData in Karlsruhe. So if you don't know what to do in October, you thought, okay, Amsterdam was cool, but I want to see other parts of the world, so come to Karlsruhe. Call for papers is open until midnight, but there are rumors it will be extended by a week. So even if you just know about the PyData in Karlsruhe now, it may be even possible to hand in a talk. And that's it.
So we have room for questions.
Yeah, so the Vega widget that you showed in the Vue code, so Vega is a specification. It's also a software stack, or is Vega a specification of a certain software stack? How does that work?
Vega is a specification, and there's JavaScript libraries implementing how it's rendered in the front end.
Is that the same team or so?
It's the same team, but it's not totally the same team. I think the people doing the spec are making their own renderer, but there are also alternative renders. Like there is, also my front-end developer said, okay, you're using Vega, it's using Canvas in the browser, but there's also an alternative renderer using WebGL or SVG in the browser, which then is maybe better on mobile also. So there's not only one thing that renders them in the browser.
Okay, so it's a pretty decent standard for graphing.
Yeah.
Okay, cool.
Thanks for your talk. One little question. How would you compare Altair to Plotly? Or is there any comparison possible between the two?
I'm not 100% sure what Plotly all does. That's my... I think Plotly is like Bouquet. It has a kind of backend server thing, and it also just is a plotting library. It's probably the same like Bouquet. If you do a lot of things in there, and you all generate it with Python code in the backend, then your front-end developers will have to dive into the Python code also to extend it. And I'm not sure about how it's with dependencies. With Bouquet, the problem also was that the dependencies in the front-end were not sandboxed. So using the Vega embed library, it just depends on Vega embed and D3. But Bouquet.js also brings in some other front-end tools, dependencies, which also are used by my front-end devs. But Bouquet.js uses a 2-year-old version, which is not compatible with the Vue.js stuff.
So how's feedback getting from the users?
The question was, how's feedback from the users? For us, it was quite good, because Vega is also really fast. So the homepage got snappier. We got a bit faster in building UIs, which also was a positive feedback from the users. I think the main positive feedback we also got was from the front-end developers, because we got rid of those Python things they have. They have to run the Flask app, but that's all. They have to just do Flask run, and then they have a backend which provides some data. That's all the exposure to Python now.
More questions?
If you tried it with really big data sets, like, I don't know, 1 million points or so?
At the moment, the problem is with really big data sets is that you have to pass this data in JSON format to the browser. You can also pass it in CSV. The nice thing is I'm in the Arrow project, and 3 or 4 days ago, Jake Vanderblas, who's doing Altair, and a colleague of him appeared in our Arrow bug track and asked, okay, we wanted to integrate Arrow into Vega. How can we proceed with that? And that's maybe a thing that was going to happen, because there are other people who are plotting millions of points in the browser. They're using Arrow. But they're not using Vega at the moment because Vega has this much overhead. That may happen, but with 1 million, I think 1 million could work, but more than 1 million will get really slow.
So maybe related to this, when you, like if you zoom in, do you need to send new data, or will you always use the data that's already there? So let's say that on the Flask side, you decide, well, I will like scale down my data points, like by grouping them if I give the whole range. But if I gotta zoom, then I will resend new data points. Is that possible, or?
By default, if you zoom in, it just zooms in with the data that's in the browser. So you can build that it gets new data points, but that's not something that's available out of the box. There are callbacks available in the front-end library, but that's also something that's in the front-end library, not in the specification. Oh. So that needs a lot of overhead then.
Thanks. Other questions? Well, let's thank Uwe again.